Hello, good morning, everybody. Welcome to our first English webinar. We've never done it in English yet, but there's always a first time for everything. We are honored to have you here as participants in this webinar. My name is Emil van Rossum. I'm the owner of Brand Preventie Academy. And all the way from Italy, virtually, is Andrea Leto di Priolo. Welcome, Andrea.
Thanks a lot, Emil, and hi, everybody. I'm Andrea Leto di Priolo. I'm the head of development of one of the manufacturers specialized in passive fire protection solutions. And it's a pleasure to be here with you for this first webinar in English. Brand Preventie Academy.
Yeah. Let me say something before we start the webinar about Brand Preventie Academy. We are a training institute in fire safety engineering in the Netherlands, providing a broad range of courses in many areas, both theoretical and practical. We strive to cover all subjects in fire safety. I will in a moment I will pass the word on to Andrea. During the webinar, you can ask questions. You can ask questions in the chat. The moment you have a question, just put it in the chat straight away, and Andrea and me, we will decide when, in which point in the webinar we will answer the questions. So then, without further delay, Andrea, the floor is yours.
Thanks a lot. Thanks a lot again to everybody. So basically, I'll now share my screen. I'll share the presentation. I hope you can see it. Please get Emil, if you hear me, if you can give me.
I hear you, and I see the presentation. So until now, the technique is going well.
So again, it's a real pleasure to be here with you. I'll try to keep this presentation as as informative, as interactive as possible. So really, as Emil just said, if you have any questions, if you would like also to ask questions after the presentation, you can write in the chat or contact us directly, and it will be my pleasure to give my best to answer, to try to answer it. So what is the program of today? Today we are going basically to treat two different topics. The first is the legislation framework for firestop penetrations. We talk mostly about European legislation framework and how this interacts with the laws of different countries. After this, we go into how to compare different systems. And this for us is the key. When we talk about systems, we are talking about systems that allow to seal true penetrations, service penetrations. And this is really the core of our expertise. We would like to provide you a scheme to compare, to benchmark different systems according to their performance and to their budget and to all the level of complexity that you have to keep in mind when applying one solution or the other. So let's dive in directly. Of course, at the end, I'll try to answer all the questions. I'll prefer to keep this section at the end, just to to focus really on the topics during the hour of the presentation. But if something is really important, I'll try to watch the chat as well and jump in with the answers. So let's start with the European legislation framework and why this is so important for passive fire penetrations, and why it's oftentimes misunderstood. We will go and try to understand the relations between European and national regulations. Then the core of the European legislation, so the performances, how we can measure how can we measure one system against another? And finally, we go through all these, these specifications that can sound bureaucratic, but at the end of the day is what really matters when we want to, put on papers the quality of our works and want to convey it to the final client what we have been working on. So the different documents that certify the performance of the products. So basically, as you know, European and national legislation act on different levels. The European legislations is really concerned about creating the single market. That means that it wants to create a space where products compete fairly to one another, where their performance can be comparable. So if if a system resists in case of fire for 120 minutes and the test is carried out in Portugal, the same product tested in Germany has the same exact performance if it has the same assessment during the test. So basically, European law really sets the field and define all the minimum product standards that should be met to make a product circulate in the union. Then the national level, there is one part that is concerned about homologating the European standards. And the most important is really the definition of the rules and the engineering criteria that need to be met in a given country. You can see basically all countries in Europe have different national standards. The countries that are more open to fire safety engineering methods are less strict, I would say, in defining the minimum requirements. There is more space given to the discretionary judgment of the professional and more flexibility to adapt the projects to the exact circumstances of the building of the projects I'm dealing with. As opposite, countries that are really prescriptive try to really list all different cases and give an exact number. Let's say, for example, hospitals above 24 meters need exactly this level of these minutes of fire resistance performance, and the compartments have exactly this size. So you see that all countries have different rules and different ways to bring to reality the performances of the products. So what is useful about this? What is useful to know? Basically, European level could be, at the first sight, even dismissed as not that important. Once you know that a given product has a certain performance and a certain field of application, you may feel that your primary duty is just to know the national rules, the criteria that you should use in your projects. The reality is, and I hope by the end of this webinar you will agree with me, is that knowing exactly how test performance work, how the products work, really can make the difference between choosing the right or the wrong system. And during inspection, it can make all the difference when you have to understand if the system has been placed correctly or in a wrong way. So basically, if you just focus on the national level, you can miss all those details that really, at the end of the day, would make it work or not what you have put in place. I will try to make this with concrete example to give you a concrete example in the following part of the presentation. Okay, so just to give you a quick look, when we talk about European standards, we are talking about mostly in this presentation European test standards. You can see there are tests for air ducts, different tests for fire dampers, different tests for pipes and cable penetrations, different again for joints. Then we have standards for service ducts and shaft, for all this kind of discontinuity that you can have through the support, through your compartment. The important thing is, okay, so we are dealing with fire resistance. What are the performances that I really should care about in all these different fields of application? And the performances that you really, throughout all the standards are repeated as mandatory for those who wants to have strong certifications are fire resistance and durability. Fire resistance, of course, because we want to grant that our products work in case of fire. But durability is equally important, and I will show you why in a second. So basically, when we talk about fire resistance, this is really the basic concept. All of you will surely know them, but still there is some, it's very frequent, a wrong use of these concepts in practice. So basically, there are three fundamental performances that combined make the fire resistance requirement. The first is the R. So the load-bearing capacity, the mechanical resistance of the element. Of course, if a wall or a floor need to provide fire resistance, need not to collapse in case of fire. So basically, we measure in minutes how much time does this element resist in case of fire. With integrity, we are going to see if the passage, if you have two compartments, if a fire produces in one of them, we look what happens on the other side. And on the other side, there should be no communication. There should be a barrier to smokes and flames. Finally, insulation. So not only my systems needs to, provide a barrier in case of fire, but also needs to provide the temperatures in the compartment when there is no fire are below a certain level, below, for example, 140 degrees on average, as a difference compared to the environmental temperature. So, if we place a system, for example, a collar to seal a pipe penetration, after 1 hour, the temperature in the room with fire will be like 900 degrees. On the cool side, the temperature should not exceed the 140 degrees above the external temperature. So you see, it's such a dramatic insulation that we need to provide within the width of the wall or of the floor. And here already the first questions, just to not make it, just to try to make it more interactive. So in your opinion, what is the hardest performance to achieve for certain time lengths with the true penetration seals? This is a question that we propose quite a lot in our webinars across Europe. And we ask you if, imagine you are a manufacturer, imagine you are going to test one of your fire-rated systems, for example, a firestop collar, and ask yourself, what is the hardest performance to achieve? If it has to resist for 90 minutes, should I be more concerned about the R, about the E, or about the I? I'll give you a few seconds to think about it. And the answer is that the answer that you get the most is integrity. So people think that the most critical variable is really the capacity to have a barrier in place during fire. The R is wrong because we are not asking in case of true penetrations, we are not pretending that the system that seal a penetration enhance the level of mechanical resistance of the support. So basically, when we talk about true penetrations, we just focus on integrity and thermal insulation. And thermal insulation, notwithstanding what we receive the most as an answer, thermal insulation is the most difficult requirement to achieve. So it's much more difficult to get a requirement of I90, like say thermal insulation during 90 minutes, than E90. And to understand that, let's imagine that you have a wall, let's say a wooden wall. So basically during fire, it gets thinner. And the same can happen with boards. If you have a wall with a different gypsum board, for example, at some point, one of the boards can collapse. In all these cases, you can have integrity because, you know, one board is still in place because there is a certain thickness of the wooden wall that is still in place. But you can lose the thermal insulation because the thickness of your support is diminishing. On the opposite, if you lose integrity, immediately you lose thermal insulation. So what we are saying is that really reaching thermal insulation is much more difficult because you can have systems that reach integrity without any problem, but cannot still grant thermal insulation for that amount of time. The other requirement that is very important, and it's always, it's often not taken properly into account, is durability. And this is, we really care a lot about this requirement because when we talk about penetration seals, we are not talking about a system where you have an obligation to change, to upgrade, to provide maintenance every 2 or 3 years. So basically, these systems are made to stay in the building for a lot of years, for 10, 25, 100 years, even in some cases. So we have to be sure that the product will act as we expect when and if the fire will produce. So not today, not when we buy, but after being exposed to some conditions that can be high humidity, temperatures below zero. And, you know, let's say in 10 years, if an occurs, it should work as when we installed it. So how can we give this kind of requirement? How can we characterize the products throughout this variable? Basically, we need to perform tests in accelerated aging conditions to be sure that the product can resist 10 or 25 years. 25 years is the maximum that is coded in the standard as an aging cycle that can be tested according to current European rules. So we have to be sure that our products, at least for 10 or 25 years, have been tested and that they work as when we put them in place. You see, it's not only about the time length, it's also about the condition of use. So basically, when manufacturers test the products, they not only ask themselves, okay, so how many years should it last? They also ask, in which condition should it be used? So you see that, for example, you have the Z2 category is the lowest. Basically, it's, it's product that has this requirement can only be used, should only be used in environment without high humidity and with temperature above 0 degrees. Then we have the Z1s that you can use, also in a high humidity conditions. And if you have Y2 condition, you can also test in environments that, for example, during winter are not heated because temperatures can go below 0. So when you move above this table, you see that the condition of use of the products is more and more challenging. So in type Y1, not only the product should resist in conditions of high humidity and the temperatures that can vary between, let's say, minus 20 degrees and 60 degrees, and 70 degrees, I should say, according to the specifications of the standard. But it also should work being exposed continuously to UV rays. And finally, in type X, the products are also exposed to all kinds of atmospheric agents. So basically, this is an information that you find in the very first pages of each ETA, the level of durability of your products. And now we come with a very difficult question. So I hope you get your coffee, you have it very next to you. Because we ask you, we try to, to make you jump on the other side, on our side. And as a manufacturer, think about what is the right, the most common condition of use that you want your products to be tested against. Imagine that the more you go towards the X category, the more cost of testing are high. But still, you maybe don't want to test products to obtain a Z2 category, because the applicability should be limited. So let's imagine you are placing your products to be tested according in a durability test. Which category would you choose and why? So basically, what I can say here is that in most cases, manufacturers want to obtain a Y2 category. So our products, our systems, true penetration systems are usually not directly exposed to the UV rays and are also not directly exposed to rain or snow or other atmospheric agents. They are not on the roof of a building. So basically, Y1 or X category is not something that you really are too concerned about in most cases. But what you are surely very concerned about is that your product really fits in conditions of high humidity and in conditions of temperatures that can go below 0 degrees, because many times these products are placed in the let's say underground parking without heating systems that can grant higher temperatures. So this is something that is always and often missed when analyzing a certification, but can make really all the difference. Because really, this kind of colors that are completely oxidated, that we see so often at the work sites, it's very difficult to believe that they can work properly if they are not tested against high humidity conditions. So, for example, if we talk about a material that should last, we should, in our experience, we should always look for an inoxidable stainless steel material. As you know, if you have a metal material that you put in place, or some kind of external finishing that really conveys this requirement of resistance to humidity. So basically, we dealt with the fire resistance requirement and we dealt with durability requirements. The last part of this first section of the presentation is about the certification. I hope not to lose all of you on this part that, can be the most, can sound as the most boring one, but it's still very important. And so basically, we need to make a clarification. The question is CE marking obligatory? And the answer is that we cannot make an answer. We can't give an answer that applies to all products. There are certain products like doors, curtains, dampers that have their own product standard. If there is a product standard, so if within the EOTA, the organization, the European organization that make the standards, there is an agreement on what a fire-rated door, a fire-rated carton, or a fire-rated damper is, and there is a specific product standard, then the CE marking is obligatory. So for these three products, you always have the CE marking. When we talk about true penetrations, in most cases, we are talking about corners, bricks, bags, panels, foams. In some cases, we can also think about joints. It's not a penetration, but it's still, a discontinuity, an opening. In all these cases, there is not an agreement at the European level on a standard, a specific standard, and there is no mandatory CE marking. So what do companies do to get this CE marking and why it is important? So basically, if we are a company, we have a company like us that specializes in true penetration, the CE marking is not obligatory, but it's still very useful because it forces you as a manufacturer to put in place a manufacturing control process that gets inspected twice a year. You see at the bottom of the slides, the specification by an external body. And what you basically are conveying to the market is the fact that you are selling exactly what you tested. You cannot vary your manufacturing process, and you are bringing it to the market. You are delivering what has been tested. So this is the added value of the CE marking. And this is why it's so important for manufacturers like us, for example, to apply voluntarily and making a very long process. You see on the right of these slides, all the kind of additional controls and processes that you should do to place a CE marking on a product when it's not mandatory, when it's not obligatory by law. And this CE marking lasts 12 months. It's only renovated if manufacturing audits pass these inspections, and it's really so a certification of quality that you bring to the market. So not obligatory, but it still marks a difference in terms of the quality that we can convey to the market. Basically, manufacturers that have under control their manufacturing, they usually want not only to have a European technical assessment, an ETA, but also a CE marking to their products. And this is also, this also the possibility to place the CE marking. Sorry, the slides were going a bit too fast. The possibility to place this CE marking really is an additional cost for the company. And I would say that in the market, when we look at the price level, there is quite a big difference between products that have CE marking and products that do not have CE marking available. So not only the ETA is important if you want to have all results, but also the CE marking plays a role, although it's not obligatory. So this is a table that tries to summarize all these concepts. The test report is the fundamental document, so you need to test in an official laboratory according to the rules defined by the European level of legislation, all those test standards that we saw before. All these test reports can be, put together in a document called European Technical Assessment, ETAs, that summarizes very efficiently all performance of a given product. And then if the manufacturing is under direct control of the producer, basically we have this CE marking application. If it's successful, the manufacturer can provide the market with a COP, that is the certificate of constancy of performance that lasts 12 months, and gives the possibility to the manufacturers to apply the CE marking to the products. Especially, this is where do you see the CE marking? You see in a separate document produced by the manufacturer that's called DOP. DOP is the declaration of performance, and you will see there all the different performance level of the products, plus the C marking if it's something that has been provided. So we finished with the first part. The first part was about regulations. I hope you really understood the importance of these two performances. The fire resistance, we focus on integrity and thermal insulation, and the durability of the systems as well, especially because we don't have, frequent controls in place for this kind of products that just act once when the fire produces, and we have to be sure that they will work in that case. The module 2 really is about giving you our way to simplify a bit the scheme to analyze and benchmark different solutions for penetration seals. So we divide this in 3 subsections. The first is aimed at providing a checklist to technically compare the different systems. The second one is to acquire better knowledge of the parameters that enable to extend certified results. We will see that, there is really little scope for extension from test results when we talk about true penetrations, but we really have to understand how the sealing system work to understand what can work and what cannot. Finally, we should see some of the common mistakes that can really affect the total cost of the solutions. So let's start. Let's start with the first and most important part, that is this checklist to technically benchmark different systems. And when we talk about true penetrations, you see these 3 images. We focus on support, we focus on the passing through element, and we focus on the sealing system. Starting with the support, why support matters? Well, support matters because of what we see at the center of the slide, because results obtained in worse, more critical conditions are valid for applications in more favorable conditions. This, I would say, is the only general rule that enable extension. And when we talk about supports, we are really in a space where what is more and less favorable is clearly defined. So basically, here we see what this is about. So we cannot say that there is a worse condition if we test it vertically or horizontally. So basically, our products should be tested on a wall if we want to apply on a wall, or should be tested on a floor if you want to apply on a floor. There is no possibility to extend the validity of results from one orientation to the other. Next, we have to look at the material of the support. And, results obtained on flexible standard, I would add, supports can be extended to rigid supports of equal or higher thickness. This is key. This is why when you see these certifications, you see often and often certifications on plasterboard walls, standard plasterboard walls, flexible walls. Why? Because if a system works in that condition, it can work in all rigid walls with higher thickness. And this is, if you are manufacturers, you really want to optimize the number of tests. So you want to test the most critical condition that can be extended towards other supports. And when we talk about rigid supports, in some cases, I need to test solutions on rigid supports. Why? Because the flexible walls sometimes cannot achieve those performances. In some countries, for example, I need to get to 180 minutes for some kind of penetrations, and usually plasterboard walls get to 120 minutes. So basically, sometimes I need to test rigid supports. And here, I can also extend results. If I test on a support with lower density and lower thickness, I can extend the validity of results towards supports that are thicker and are more dense. Why this is relevant to you? Because when you have a certification, you should not only look at the performance, you should really look at the supports where it has been tested. There are a lot of, extensions that are, I would say, commercially communicated to the market, from supports that are thicker towards support that are thinner, based on some kind of experience of the manufacturer. There is not such a thing. You can say that something works on a thinner support only if that support has been tested. So this is basically what we saw about the extension possibility from flexible supports towards rigid supports. We should say that not all flexible supports are the same. There are supports that can be considered standards and support that can be considered not standard. In the most recent version of the guideline, the EAD and of the standard, there is possibility to test on lining walls that are considered standards. So also VSF systems tested on this 30 millimeters thickness lining walls. And, since it is standard, the validity of results can be extended towards other supports with similar composition and higher thickness. Then there is also specification about wooden walls and wooden supports. So you see that the more the time passes by, the more not standard supports get added to the standard. What is not considered standard is always a sandwich wall or floor. Basically, it has to be tested specifically each sandwich wall or floor, because there is really no specification of extension possible in the European guideline for this. Of course, common sense is also used, because you cannot test all kind of different thickness of the metal of the sandwich wall and floors. But still, this is to say that you really should look at the variety of supports where the product has been tested. If a product has not been tested on a wooden wall or on a sandwich wall, it cannot be applied to it. Okay, so we dealt with the supports, and now we go to the true penetrations. This is clearly the most important specification. So basically, we can have cable or we can have pipes. This is the, as summarized as it can get. When we talk about cable penetrations, we need to, first of all, we need to be sure that we are talking about cable penetrations and not other, kind of electric discontinuity, for example, interrupters, or, in some cases, I want to provide additional resistance to cable, but not for penetrations. What you see on the right of this slide, you have, for example, you have some kind of paint that are not aimed at providing resistance to the true penetrations. Basically, I paint cables because I want the flame to stop. So it's not in correspondence of a wall or a floor. I am in a room. I have, let's say, for example, an airport big hall. I have these cables. I paint 1 meter every 20 because I want that the flames stop when they get to this painted meter of cables. So this is not what we are talking about when I talk about cable penetrations. When I talk about cable penetration, I always need a support. I always need a support that gets completely crossed by the elements. And the cables can be, can be on cable trays or can be on corrugated pipes. Should not be, but sometimes even we find them without an external protection, without a pipe around, and we still have to deal with this kind of discontinuity. What should take in account, basically, there are three sizes of the cables that are relevant. 99% of the cases in civil constructions, we deal with small cables. Diameter is below 21 millimeters, but there are also cables, there is possibility, especially in industrial environment, for cables of medium or large size. This is relevant because the system that works for small cables does not necessarily work for medium or large cables. Also in our product range, when we tested for medium and large cables, we needed more sealing depth. We needed, let's say, more protection within the penetration. The second specification is the tray type. Of course, there are different tray types. So if I provide a solution for a specific tray type, I should be sure that it's covered in certifications. And finally, the opening size. The opening size is something that is not specific of cables. We should always fill what is around the penetration with the material that is fire resistant. Here we see an example. So basically, we see two openings with cable penetrations, and we see what I was referring before to. This is out of our catalog, so I don't want to make it a commercial in any way. I just want to say that for small cables, we use 120 millimeters steel in depth, and for large cables, or even mixed configuration, we need 200 millimeters. So you should really look within the certified configuration at what has been tested for the size of the cables. It can get so complicated because, of course, at work sites, every opening can be different from one another, that in the standards that have been defined what has been called standard configuration. So basically, if the manufacturer tests one of these configurations, you can be sure that it's valid for all kinds of cables up to that diameter. And so this is another thing to keep in mind when you see these 60 by 60 centimeters, for example, openings with all the range of different cables from small to large ones. You are in front of a configuration that allow the maximum extensibility of the results. So basically, you can have all kinds of different, cable trays in there, and even a different number of cables compared to the one tested. And if all the elements of the standard configurations are present, you can be fine with that. When we talk about pipe penetration, instead we talk, I think it's quite clear now that we need the support to have this penetration. And when we talk about pipe penetration, we divide the space into 4 blocks. We can have combustible or not combustible pipes, and we can have pipes with insulation or without insulation. Why this is important? It's important because you clearly treat differently all these cases. And I want to, okay, this is, there is a lot more technical insight that I can give you, but I want to stop here to show you what I mean, sorry, when we are saying that we need to treat very differently something that is combustible from something that is not combustible. So I stop 1 second with this presentation, and I'll try to share another screen. So here we go, and basically I want to show you a video. So this video, I will show you 2 videos. This video deals with combustible pipes. So basically, you will see here a real test. So you see the furnace. Inside the furnace, there are the fire-rated collars. We are clearly on the cold side. You see the pipes are open on both sides. This is clearly the most challenging configuration. Why? It is what has been referred to as a UU configuration, because clearly there is higher pressure in the furnace. So if you have this kind of configuration, there is a flow of hot air from the inside of the furnace towards the outside of the furnace. This is so critical that the pipes that have been tested with this configuration, the results can be valid for all kinds of different configurations. So let's see what happens in practice. So basically, this is accelerated at 8 times. I put play just now. These are PVC pipes. It's a very old test. I think it was made in 2010. And you see something is happening now. The opening is closing off. And my question to you is, what's happening? Is it the color that is working, or is it something else? And if you say it's something else, you are right, because basically now it's not the intumescence that is working, but it's the plastic that is melting down. So this is interesting because you can see really what happens in a test. So if you have a combustible pipe, the combustible pipe starts melting down at 80 degrees usually. And this is before the intumescence starts working. The intumescence starts working at 180 to 100 degrees. So in some cases, the plastic collapses completely before the intumescence acts. The important thing is, of course, that fire does not get to that the openings are completely sealed in a short amount of time, and the fire does not get to the cold side. So basically, the plastic pipe on the cold side is still integer. And this is also a guarantee that the temperature on the cold side is below, on average, below the 140 degrees that we were commenting before. So why this video? This video because I really wanted to make a point that we need this kind of thermal expansion, this kind of intumescence when we deal with combustible elements. But then let me go to another video, because when we deal with metal pipes, it's completely different. Metal pipes, let's say steel pipe, do not melt down. So why should I protect them? And the answer is that I should protect them not because of integrity reasons, but because of insulation reasons. So what you see, so basically, here you see a coating, a mineral wool coating around a metal pipe, for example. Our aim here is not to thermo expand, to close off an opening. Our aim here is to cool it down. And we do it in this system. We can use, usually mineral fibers mats can be used or semi-rigid protections. In this case, we see in action something that is a bit more rare. It's an ablative coating. So basically, we don't use the thickness of the mat. We use especially a coating that is on the inner side of the mat that release water during fire. So until the since the steam water evaporates at 100 degrees, until the complete evaporation of the coating, the temperatures remains at 100 degrees. So you see, this system work, it cools down the metal pipes because the energy is not used to increase the temperature of the pipe, but to create this chemical reaction. The chemical reaction is absorbing energy. And you see clearly that water is producing, and until the complete, until water is produced, the temperatures is below 100 degrees. So I come back to the presentation now, and I'll get back to the PowerPoint. Right. So here where we were before. So it's very important that this concept, you have it very clear. Every time you have a combustible element, you should look for something that thermo expand, like intumescence. Every time you don't have this kind of problem of elements that are combustible, that during fire will disappear, then your focus moves towards the insulation. If you have metal pipes, you should really find systems that cool them down. I just skip a bit this part. I just go very fast through it. I mean, basically, if you have a pipe, of course, higher diameter, test on higher diameter, cover applications on lower diameter if the system is the same, meaning if you have the same quantity of intumescence. Then you should look, of course, at the insulation. If you have a pipe with insulation, results on it should be tested. It's not possible to extend from a pipe with insulation towards a pipe without insulation or vice versa. The thickness of the pipes. Basically, if you have combustible pipes, there is no way to say that a thinner pipe or a thicker pipe represent a worse configuration. So there is no extension possible. So you always have to look that both thinner and thicker pipes are tested. And finally, what we said about the pipe end configuration, we already saw that uncapped configuration, so completely open pipes are the most critical conditions, but it's not, in most cases, a UC configuration. So when in the cold side, outside the furnace, you have a cap is enough. Why it is enough? Because you see, this is also what the standard, this is the old version, but this is basically what the European standard recommends. So if you have pressurized piping, like gas, drinking water, chilling and cooling pipes, you just need an uncapped capped configuration. And so basically, with the UU, you are sure you fit to the requirement, but UC is okay for the big majority of cases. Finally, the sealing systems. And okay, we are 7 minutes. We have 7 minutes to go, and I think we are perfectly on time. Here is probably where most traps hid. Why? Because, okay, because in practice, in many cases, we see shortcuts. And we see that we don't think about what is passing through a penetration. We don't think about the material that we have at hand. And so we see many times, for example, that the wrong product is used. Let's make an example with foams. Foams are, under huge debate in many countries in Europe. But the reality is that there are good and bad foams, I will say. Foams that expand during fire and foams that do not expand during fire. Here we see two products of AF systems. Neither of them is a bad product. So just but the use is different. So we see that the first product, for example, is a fireproof polyurethane foam, single component. The second one is again a fireproof polyurethane foam, but it's a two component and it's additioned with graphite. The first one expands up to 40 times when it's applied because it's under pressure. So basically, it's like the foam for the bird, right? I mean, it just increases its volume. But and the second one instead just 3 to 5 times. These are our old public prices. So you see that the first one is by far cheaper. So it's good that we can talk about our products so we don't get claimed by other companies and so on. So, but here is what you see also across the markets. So the monocomponent and not expanding foams are clearly cheaper than the two-component expanding foams. And the point is that, of course, if one looks only at this data, one should always go for the polyurethanic single component foam because it's more product, it costs less, and it's EI 120 like the other one in terms of performance. But then we should really look at what is the alloyed field, certified field of application, because the first product is always only good if we have empty openings. So since it does not expand during fire, the single component polyurethanic foam, usually you see it in pink in most cases, it's only good for joints. It's only good for openings without major combustible elements. The second, instead, expands, it's true, expand less 3 to 5 times when you apply it, but in case of fire, it expands. And in many cases, you don't even need to put additional colors because it does it all. It has all the action to, to replenish what's disappearing. So this is important because, there is no good or bad product, but you really should focus on what's the material of what's passing by. And we see that if you have combustible elements, you need some kind of, thermo expansion or a mechanical closure that comes at some point. Here, another thing that you should look when you have to choose the product to seal is what we refer at the beginning, the basic concept. So basically, you see this is our ETA of the intumescent brick. This is, in the first pages of each ETA, not only of systems, but of every player, you see this kind of data like Y1, Y1 condition of use, so high humidity and temperatures that can go also below 0, and how much time, 25 years, that to our knowledge is the maximum that you can certify against according to the standards. So this is something you should look at when you look at the ETAs, not only to the performance, but also to the fire performance, but also to durability. Again, another thing that you should definitely take a look at, if you have looked very well at certification, then you should look at how it is installed, because here is where most of the traps are really hidden. And I'll show you with one example. So let's imagine that we have, okay, this is a very difficult example maybe for this hour. We are at the end of the webinar, but I will guide you through it. Let's imagine that you have this opening and you have an intumescent brick of a given size. Let's say in our example, it's 100, 300 millimeters times 50 millimeters. My question is, how many bricks do we need to seal the opening? And the right answer is that, of course, it depends by the configuration. How has this brick been placed during the test? Because, if it has been placed with the shore side as sealing depth, then you can just use 6 bricks. But if it has been placed with the long side as a sealing depth, then for every level you need 3 different bricks and you need 18 bricks. So it's not only the opening size, it's not only the product you choose, but you also have to understand how it has been placed. Here it's even more evident because here we have a cable trace passage and you see different systems, but the first one uses the shore side as a sealing depth. So you need way fewer bags to seal the opening. And not only that, in the other systems, you also need gypsum boards and in some cases, even additional bags, pillows. So basically, you should not stop at the cost per product to understand how much does it cost to put to place a correct installation to do properly your work. But in order to optimize your budget, you should compare all the cost of the solution. You know, it's like when we book some of those flights, and the costs in one website are completely, you know, everything you should add the cost, and in some other case it's a whole package. So you can't compare Apple with peers. You should look at all the elements that compose the solutions, and the focus should then shift from product cost to cost of the complete solution. Maybe in this example that we see, the cost of the pillow is 2 times for the manufacturer on the left, but the cost of the solution is still much cheaper when we take into account the installation additional cost, the other material. In some cases, we even have to paint the cables. So we should really, the cost is the total cost of the solutions, not just the cost per unit of the main product. And this, okay, I conclude with this one. Basically, this is these are pictures, unfortunately, also from our clients, because we always want to you know, to take examples. So you see in the left part, you see a very creative application for this. We are in pharmacy, and they placed our square collar around this passage for the medicines. I mean, it works like a damper, so the intumescence comes and closes it off. Unfortunately, it has been tested with exact passage. It's a very creative solution. Technically can work, but it's not tested. And you know, definitely in this there is a problem here, because there is also a metal bar inside. So really, you should make a dedicated test for this kind of configuration. On the right, what we see on the right, we see some client that placed the foam that does not expand and put bags in it for a cable tray. This is completely wrong, also because the foam will act against the expansion of the intumescent pillows. So basically, we should remove the foam in this case. And finally, on the bottom right of the presentation, you see these intumescent collars placed on a metal pipe. And this also makes little sense, because unless we are with aluminium, with a pipe that at 600 degrees starts to melt down, if we have a stainless steel pipe, we should really try to keep it cool and not, you know, act with intumescence in the passage. So with this slide, I hope there is a very long, wordy sum up, but I save it from those of you that would like to read it if they want to have the presentation directly. And I tried to make it as pragmatic as coming out from our experience as possible. I hope it was useful. And of course, these are also the contacts. If you have further questions, we will be happy to answer also after this webinar. So Emil, I'll give it back to you.
Thank you.
The president.
Yeah, thank you very much. It was, as we were talking about before, Andrea, it was not a record in viewers this time, or at least not a record upwards in viewers, maybe a record down, but then everybody got some special attention, so to say. Thanks everyone to participate in this webinar. Can you please give us a thumbs up on YouTube, and if you're not subscribed yet to our channel, please do subscribe. And yeah, we hope to see you next time on our webinar. Have a good Friday. Thank you very much, and thank you, Andrea.
Thanks a lot, Emil. Thanks to all of you. Thank you.